What if the first alien signal humanity receives isn't a message, but a smell, a chemical scent drifting across 124 light-years, not from technology, but from biology, not a radio wave, but a molecule? In 2025, the James Webb Space Telescope turned its eye to K2-18b, a distant world shrouded in a thick, hydrogen-rich atmosphere and endless oceans. And from that atmosphere, it captured something stunning: dimethyl sulfide, or DMS, a compound that, on Earth, is only known to come from life, from plankton, from life that breathes, grows, and dies in the sea. What if, instead of listening for alien voices, we've just caught a chemical whisper, a molecular exhale from a living ocean far beyond our own? Could this be the first sign of life outside Earth, not intelligent, not complex, but unmistakably alive? Before we explore the science, the theories, and the possibilities, pause. Imagine that moment. The first time humanity smelled the breath of an alien ocean, the search for life just got a lot more real. In the vast gallery of exoplanets discovered so far, most are worlds of fire or gas, scorched, stormy, or utterly uninhabitable. But K2-18b stands apart. Roughly 124 light-years from Earth, K2-18b orbits a red dwarf star in the Leo constellation. It's what scientists call a Hycean planet, a rare class of exoplanets that could harbor vast oceans beneath hydrogen-rich skies. These planets are bigger than Earth, warmer than Neptune, and potentially alive. In September 2025, the James Webb Space Telescope, JWST, peered into the atmosphere of K2-18b and made a discovery that electrified the scientific world: dimethyl sulfide DMS. On Earth, DMS is a biological signature. It's produced almost exclusively by marine plankton, tiny photosynthetic organisms that live in Earth's oceans. We've never detected DMS anywhere beyond Earth, until now. The detection isn't conclusive proof of alien life. The signal is still faint, and the data is under intense scrutiny. But here's what makes it so thrilling. No known geological or chemical process can easily explain DMS in such quantity without life. Scientists are cautious. Peer reviews are ongoing. Some propose alternative sources like volcanic plumes or cometary chemistry, yet none fit perfectly. The best explanation? Microbial life, quietly exhaling into an alien sea. K2-18b may be too hot, too wet, or too strange for Earth-like creatures. But for the first time, we've seen a possible chemical fingerprint that echoes what life looks like here, even if it's a whisper from deep within an ocean we may never touch. The universe hasn't answered us with a radio signal. Instead, it may have sent us a scent. Sometimes, to understand the extraordinary, we need to return to the familiar. On Earth, dimethyl sulfide DMS is not exotic. It's part of the planet's daily breath. As marine plankton photosynthesize and break down, they release DMS into the air. We can actually smell it, that faintly fishy scent by the coast. That's life, exhaling. This compound plays a key role in Earth's climate, forming clouds and reflecting sunlight. Yet despite its mundane nature here, DMS is profoundly special. It is biospecific, meaning, as far as we know, it's only made by living things. So when JWST detected possible traces of DMS in the atmosphere of K2-18b, scientists didn't just find a chemical. They found a pattern, one that perfectly mirrors what we see in our own biosphere. That's why it matters. Because science is built on comparisons. We find confidence not just in discovery, but in consistency, in repeatable processes. If DMS appears on another planet, under similar oceanic and atmospheric conditions, it begs the question, has life followed a similar recipe elsewhere? We don't know what form life might take on K2-18b. It could be microbial, alien beyond imagination, or fundamentally different in chemistry. But the fingerprint looks hauntingly familiar. as if nature, across light years, had reached the same biological solution. That's the beauty and the mystery. If two planets, separated by time and space, echo the same molecular breath, then maybe life isn't a miracle. Maybe it's inevitable. The discovery of possible life markers on K2-18b didn't just spark curiosity, it ignited a movement. Across space agencies, observatories, and laboratories worldwide, scientists are now racing to confirm or refute the signal. Every data point is reanalyzed. Every alternative explanation is tested. Is it noise, a trick of molecules, or something truly alive? NASA and ESA are already planning next steps. Missions like LIFE, Large Interferometer for Exoplanets, and Habitable Worlds Observatory aim to peer deeper into alien atmospheres, not just of K2-18b, but of dozens, even hundreds, of other Earth-like candidates. These missions will hunt for chemical fingerprints, oxygen, methane, carbon compounds, and yes, DMS. Meanwhile, here on Earth, chemists are working to recreate DMS in simulated alien environments. If it can form without life, we need to know. But so far, every scenario points back to one conclusion: biology. And the search isn't limited to telescopes. On moons like Titan and Europa, where liquid oceans hide beneath ice, robotic probes like Dragonfly and Europa Clipper are on their way. Their goal: to taste, test, and maybe, just maybe, touch something alive. This is humanity in motion, a civilization hearing a distant whisper and choosing not to ignore it. We're no longer just asking, is there life out there? Now we're asking, where do we point our eyes next? Because if life truly is calling, we have a duty to listen. Let's imagine for a moment that it's true, that beneath the thick hydrogen skies of K2-18b lies a global ocean, dark, pressurized, and ancient. There, drifting through the currents, microscopic life forms float, divide, and evolve. They do not build cities or send signals, but they live. They feed on energy from the planet's interior, or perhaps from rare flickers of starlight that reach the upper layers of the sea. In the process, they release dimethyl sulfide, the very same molecule that now hovers like a whisper in the planet's atmosphere. We will never see them, not with today's technology. No probe will dive into that ocean anytime soon. But the chemistry they leave behind, that faint signature etched into the light, has already traveled across space. And we caught it. This would be the first alien life ever detected, not through contact, but through consequence. And maybe, just maybe, this life isn't alone. What if K2-18b is only the first of many? What if life, like stardust, is scattered across the cosmos, not rare, but inevitable, wherever oceans meet energy? It wouldn't be the science fiction fantasy of flying saucers or green men. It would be something older, deeper, quieter, but no less profound. A silent truth waiting under the waves. Whether or not life truly exists on K2-18b, one thing is certain: we're not looking at the universe the same way anymore. For decades, the search for extraterrestrial life focused on Earth-like planets, orbiting sun-like stars with conditions just right. But K2-18b rewrites that narrative. It shows us that life may arise in places very different from our own, beneath alien oceans, within hydrogen skies, orbiting faint red suns. It also redefines what a discovery means. We haven't seen cities or signals, no alien faces staring back at us, just a molecule drifting in starlight. But that molecule speaks volumes. It tells us we're getting closer, that life might not be rare, just subtle. The greatest discoveries often come quietly, a ripple in data, a chemical hint, a shadow in the light. Yet they shake the foundations of how we see ourselves. Because if life exists out there, even in its simplest form, it changes everything. It means Earth is not unique. It means biology is a universal language. And it means we are not truly alone. This is not the end of a mystery. It's the beginning of a revolution. So we keep watching, listening, wondering, not just to find life, but to understand our place among it.